Today what we're going to do is we're going to look at integration techniques that you can use on definite and indefinite integrals. These are some of the techniques that we're going to look at. Now, method of substitution. Well, the rationale is to make a complicated integral easier. Okay. I'm going to let u be the tangent of x. Why? Because we know that the derivative of tangent x is secant squared x. So du, now remember, 1 over cosine squared is secant squared. So this is u to the 4th in u. 1/5 u to the 5th. Don't forget your constant. But what was u? U was the tangent of x. Okay? Now, I would suggest you pause the video and you work these examples. Okay. And I want the thickness to be a little better. Alright, here I'm going to start by factoring out 4/7, and I'm not even going to use a u substitution because I immediately recognize this as a derivative of an arc sine. So this is 4/7 the arc sine of x plus constant. Now here, you need to be able to use u substitutions. The quite famous questions is they give you a u substitution and they say, hey, you go manipulate this. So this becomes 1/3 e to the stuff d stuff, which is 1/3 e to the u plus a constant. But what was u? U was x cubed plus 2 more. Well, u squared plus 1 over 2 is x. Okay. Now, when I saw in my mind, I see this as u squared is 2x minus 1. So 2u du is 2 dx. So u du is dx. So my integral, what is x? X, I'm going to factor the 1/2 out. U squared plus 1 times this, but the square root of all of this was u. And what is dx? U du, which is 1/2 u to the 4th plus u, which, okay, it's 1/5, but that's a 10th, u to the 5th plus a half times a half is a 4th, u squared plus constant, and then finally we do our substitution. But remember what u is, 2x minus 1 to the 1/2 power. You may see them do some factoring here to simplify. But if I square a square root, I get just the radicand. Okay. I wonder if u is the natural log of x. Why? Because this is to a power and its derivative is right there. So du is dx over x. So this is u to the 4th in u. 1/5 u to the 5th plus a constant. It's 1/5. The natural log of x all to the 5th power plus constant. Now, this one is a sneaky one. Because, see, I look at this and I see arctangent. Because I seem to remember that the derivative of arctangent of an angle is 1 over 1 plus angle squared. So the first thing I'm going to do is rewrite e to the 4x as e to the 2x squared. So if u is e to the 2x, du is 2e to the 2x. So I'm going to double and multiply by a half. Don't forget your dx like Mr. Isaac. So this is 1/2 du over 1 plus u squared. So 1/2 the arctangent of angle u plus constant. However, angle u was e to the 2x. As you can see. Now, there's a couple different ways to do this one. Is the derivative of u of the square root of x 1 over 2 root x? Well, look, that's right here. So I could do this one of two ways. I'm going to be greedy and let u be my numerator. So du will be dx over 2 root x. So this is 2 in u, which is u squared plus constant, which is 3 plus root x squared plus constant. Now, there was another way I could have done this. I could have rewritten this as this and integrated it. It's algebraically, it'll be equivalent. It just means the constants would be way different. Now, integration by parts, it's how we integrate a product. Okay. So I'm going to let u be x. Why? Because I can eliminate it. I'm going to let dv be cosine x. So the antiderivative is going to be sine x. So it's u times v x sine x minus the derivative, or the integral of sine x and x. But that's x sine x plus cosine x plus c. Now this one's an interesting one. I'm going to let u be ln x, because I don't know how to integrate ln x right now. I will in a second. I'm going to let dv be dx. So v is just going to be x, and du will be dx over x. So x ln x minus, but 1 over x times x is just 1. So this is x ln x minus x plus constant. Now, this is a similar problem. We're going to let u be ln x, so du will be dx over x. We're going to let dv be x. Its antiderivative is 1/2 x squared. uv 1/2 x squared ln x minus 1/2 x squared times 1 over x is x. So this will end up being 1/2 x squared ln x minus 1/2, oh, not 1/2, excuse me, 1/4, because, okay, what's going on? Sorry, technical difficulties. Okay. Alright, anytime I have a monomial, I try to let that, typically, unless I'm dealing with logs, I like to get rid of it, so I let that be u. And that means 5 to the x is dv. If I take the antiderivative of that, that should be 5 to the x divided by ln 5. So this is x 5 to the x divided by ln 5 minus 1 over ln 5, the antiderivative of 5 to the x and x. my final answer is x 5 to the x over ln 5 minus 1 over the quantity natural log 5 squared, 5 to the x plus a constant. And this one is an interesting one. I've never done this one before. I looked at this like, woohoo, this looks interesting. This is an interesting complication. So I'm going to let u be the sine of the natural log of x, and I'm going to let dv be dx. So that antiderivative isn't bad. This derivative will be the cosine of the natural log of x, but the derivative of natural, oh, look at that. So when we go down, uv x sine ln x, but this x times this 1 over x simplifies. Okay, this is interesting. It's I'm going to have to think about this because let's try that again. Whoa, come back. So u will be cosine ln x, so du will be minus the sine of the natural log of x over x. dv will, you know what, this might be a repeated one. Let's find out. Will be dx, so v is x. So what I'm going to do, we'll come back. I want to, is there a way to insert, maybe I can do it right here on the fly. There we go. And I just want to blank. Alright, and we had, hold on. Okay. Let me just delete a couple of things, folks, and get these out of our way. So I just have some workspace. Okay. Alright. We had cosine the natural log of x dx. Now, from before, it'll be x cosine x, x cosine ln x, cosine x minus, and will become plus. And notice these x's will simplify. Plus. Fine. Now I'm going to put Humpty Dumpty back together again. We had the sine of the natural log of x in x. In x. Roxy, you need to stop for a second. So this was x sine ln x. And then we were going to subtract off this. So this would be minus x. Oh, this is a beautiful problem. I didn't even plan this. It just happened this way. Now notice, look at this integral and this integral. They're the same. So I'm going to add it and divide by 2. Therefore, the antiderivative of the sine of the natural log of x in x is 1/2 x sine ln x minus x cosine ln x is constant. And I'm going to stop this video here so that I can add on to it later. Come back and continue where we left off. I picked a problem I had never done before, and I brought in a beautiful integration technique, integration by parts, where I repeat it to get an integration by parts equation and solve for the integral. Now I'm going to look at a table problem. This is rapid integration by parts. This cell will never be used, and that for me is going to be the sine of x. So I like to use monomials when I can to get rid of them. So those are, whenever I can, they're my u's. So this is 4x cubed, 12x squared, 24x, I may have to add another page here, So let me, you know what, we'll just keep doing it. Oh no, we can't do it over there. Okay, 24x, and then 24, and then 0. So what do you take the derivative to get sine? Negative cosine. Okay, what do you take the derivative to get cosine? Negative cosine, negative sine. So then this is cosine x, and this is sine x, and then finally minus cosine x, because I'm running out of room. Plus, minus, plus, minus, plus, and then we're going to integrate over here. I'm off the screen, but remember this is a 0. So this is minus x to the 4th cosine x. Okay, the product of two negatives is positive. 4x cubed sine x plus 12x squared cosine x minus 24x sine x minus 24 cosine x plus constant. Now I'm hoping that this, what I'm about to try, works. I couldn't get it to work earlier today. We're going to try it right now and see what happens. I'm going to try dragging my TI Inspire on. You know, it just, when it rains it pours. Okay, I want a calculator. We're in calculus class. We want to do an integral. It was x to the 4th times the sine. Oops. No, it. Oh, hold on. You know. And I'm going to drag this over, so I integrated that so you can see that we came up with the same answer. Now the Inspire doesn't give us constants, so we have to be careful. I've never done until today. I've never used PowerPoint to do this, so the problem is I don't like the fact that I can't make it bigger, so I'm going to have to figure out how to make that better. So I put e to the 2x here. This will never be used. The antiderivative is 1/2 e to the 2x. Then I go until the table is, I almost changed it up to 4x, until the table is level. 1/16 e to the 2x. And we take our diagonals. But when we go this way, remember 0 times anything is 0. Plus, minus, plus. This is just repeated integration by parts in a table to speed up time. So we have 1/2 x cubed e to the 2x minus 3/4. Oops, I forgot the x squared, e to the 2x. 6/8 is 3/4. 2x. 6/16 is 3/8. E to the 2x plus constant. And I'm going to go and double check that on my Inspire. And, let me just, I'm going to have to do it over here and just drag it over because it just isn't cooperating today. But, that happens. So I'm going to type in x cubed, get out of the power. I'm going to type e to the 2x. And I'm going to integrate in terms of x. And as you can see, we came up with the exact same answer. You know, maybe I can just shrink that down. Okay. Wait a minute. We've already done that problem. Okay, trigonometric functions, rationale. We just want to integrate them. So typically, these are powers. That's the first one we're going to look at. So we're going to be using some identities. So one of the identities that you need to remember is the sine squared and cosine squared of the same angle when added together is 1, because we're going to manipulate that. And the other two Pythagorean identities that come from that. Okay, here I know that the derivative of tangent is secant squared. So if my memory is correct, we have cosine squared x plus sine squared x is 1. The tangent is the sine divided by the cosine. So if I'm going to divide everything by cosine squared. So 1 plus tangent squared x is secant squared x. Eventually I'm going to need that, but here I don't. I'm just going to let u be tangent of x. I'm overthinking this one. Du is the secant squared. Don't forget the angle like I did, dx. So this becomes u cubed in terms of u, 1/4 u to the 4th plus a constant. So 1/4 tangent to the 4th of the angle plus constant. Oh, so I'm going to rewrite this as the sine of x times the sine squared of x in x. However, the sine squared is 1 minus the cosine squared, so I skipped a step and did that in my head. This one you should be able to do. Right? So what do you take the derivative to get sine? Minus the cosine of x. If u is cosine of x, du is minus sine of x, so this is plus 1/3 cosine cubed x plus constant. Well, you know what? Let's check this. Let's take the derivative of this. What is the derivative with respect to x of minus the cosine of x plus 1/3 cosine cubed x plus constant? The derivative of cosine is minus sine, so the opposite of minus sine is sine x. That checks. Plus, I'm going to use the chain rule. The 3 comes down. Cosine squared x times minus sine x plus nothing. This simplifies out, and we are left with this. So we did it correctly. Alright. This one isn't as trivial. I can't do it in my head. So this is the cosine of x times the cosine to the 4th of x. And don't forget the dx. But that is the cosine of x times 1 minus sine squared x squared in x. But that is cosine of x 1 minus 2 sine squared x plus sine of, not sine to the 4th power, sine to the sine to the 4th. Okay, if is sine x, du is cosine x. So we got to be careful here, because that's going to work for these two integrals. So I'm going to rewrite this as cosine x and x plus, and this one I'm going to write as minus 2 sine squared x plus sine 4th x cosine cosine x dx. So what do you take the derivative to get cosine? Better be sine x. Plus, now this is minus 2u squared plus u to the 4th in u, which is the sine of x minus 2/3 u cubed plus 1/5 u to the 5th plus constant. But what was u? U was the sine of x. So this is the sine of x minus 2/3 the sine of x quantity cubed. Don't forget the x like Mr. Isaac. Plus 1/5 the sine to the 5th of x. And finally, don't forget to, whoa, what just happened there? Add a constant. Alright, I seem to remember that the derivative of the secant of an angle was the secant of the angle times the tangent of the angle. So u is secant x. But before I do anything, I'm going to rewrite this integral. So the first thing I'm going to do is, this is the secant to the 4th of x times secant x tangent x in x, okay? Which becomes the antiderivative of u to the 4th in terms of u, which is 1/5 u to the 5th plus constant, which is 1/5, but what was u? It was the secant of x to the 5th plus constant. Usually we're going to be doing this so that we can rewrite this to have inverse trig functions, to maybe even have logarithms. It's just rich. It's just very, very rich. Well, the first thing I'm thinking is, well, I don't have any x's in the numerator, so I'm going to say, hey, let's okay, and I'm going to rewrite this as dx over, and I'm going to put the 2 here. Okay. Now, I'm beginning to think this is arctangent because if you remember, and I'm worried that I don't have enough room. So the first thing I'm going to do is I'm going to come over here and I'm going to factor a 1/2 out. So, okay. Then I'm going to bring that 2 within the square, so this is x plus 1 over root 2. Okay, so u is x plus 1 over root 2. So du is 1 over root 2 dx. So 1 over root 2. Hold on here, hold on. Whoa, 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 whoa. And then I need to multiply this by root 2. So this becomes root 2 over 2 over du over 1 plus u squared. So this is root 2 over 2 arctangent of the angle. Don't forget to add the constant like Mr. Isaac. But what was u? U was the sum of x and 1 all over root 2. But now notice, it's just algebra. And algebra can be beautiful. Oh, this is the one. I'm going to start with the u substitution. Okay, so du is 2x plus 4 dx. So first thing I'm going to do is I'm going to double and cut in half. Okay. Now I have the 2x. Now, on top of that, please bear with me, I'm going to add 4 and subtract 4 on the inside, because when I add and subtract the same number, that's adding 0. Okay. So this is 1/2. Okay, this is 2x plus 4. Now that's a natural logarithm, ready to go. But this other one is minus, but 1/2 of 4 is 2. This is dx all over x squared plus 4x plus 5. Okay. Oh, this is a mess. This is just a hot mess. So let me just do this though. Okay. Now look here. Here is du. So this is the natural log of the absolute value with the 1/2 in front of x squared plus 4x plus 5. Over here, we're not quite ready to go. So what we need to do is complete the square. So if my memory is correct, x squared plus 4x plus 4 plus 1. So there's your 5. That's the same as x plus 2 quantity squared plus 1. So that's an arctangent. So this is, well, I'm going to add a page that I can write on. Okay. And we have dx over x squared plus 4x plus 5. Now we know that x squared plus 4x, I'm going to write 5 as 4 plus 1. This is x plus 2 squared. So this is dx over 1 plus x plus 2 squared. So this is the arctangent of x plus 2 plus constant. So when I come over here, this is minus 2 arctangent of x plus 1 plus constant. But now notice, we not only had to multiply by 1, we had to add 0. So just the techniques and how they add on to each other is just amazing. You just need to take your time. And look, you're going to make mistakes, so don't worry about it. So when I look at this, I'm wondering, could it be arcsine? Oops, don't forget the x like Mr. Isaac did. Hi, Roxy. Okay, so what are we going to do with this? Well, here's what I'm going to do with it. I'm going to factor a minus 1 out, and that's x squared plus 2x. What are we going to add there? And we're going to add 24 there. Half of 2 is 1, so I'm going to add 1, but I really subtracted 1, so I add 1 there. So this is 25 minus x plus 1 squared. That looks pretty good. I'm going to factor out a 25. So this is 25 times 1 minus x plus 1 squared over 25, which is 5 squared. And now I'm just going to take the square root of this and the square root of that. And if these are all equal, I hope that the square root of 25 is still 5. But remember, that's in the denominator. And this is the integral of dx over the square root of 1 minus the quantity x plus 1 over 5 squared. So if u is x plus 1 over 5, du is dx over 5, which is right there. So this is du all over the square root of 1 minus u squared. So this is arcsine of u plus constant. But what was u? U, my friends, was x plus 1 over 5. Now just notice, we've done some, I wouldn't call these trivial examples. I would call them challenging examples. And we've added on to them. So I hope to finish up these examples tonight with you. And I hope that this has helped.